Okay, today's video is related to solubility curves, and these it's chemistry, of course, and well, we have some questions to deal with, and solubility is a topic that is covered in high school, I guess, and in college also. So basically, what it means to be soluble is typically a solute would be dissolving in a solvent. So let me see if we can get going a little bit on that first. So the solute, okay, is, say for instance, you would be putting salt, okay, in water, okay, or sugar, and that would be your analogy. So the sugar or the salt is referred to as a solute, and then the water here is the solvent. Okay, it's what does the dissolving. So the water here, in this case, does the dissolving. Well, some things are not going to dissolve. Some things are. Some things dissolve at different rates, and that's where we get these curves. And as you see, the temperature changes, things dissolve more or less, and we'll get into that curve in a moment. All right, so in this case, solubility curves are going to be based on water, okay, for this solubility curve we're looking at here. Now, what does it mean? It means how many grams, the grams of the solute are going to dissolve in 100 grams of water, or also known as H2O. So this is the value, and we call that solubility. Okay. Now we have a few problems to deal with here, and we're going to try to knock these out. But in general, you see the grams of solute over 100 grams of H2O is our definition of solubility. And solubility, you will eventually learn, is proportional to temperature and proportional to agitation, and maybe another factor or two. Diameter of the solute, that affects it. So smaller solutes dissolve faster, stuff like this, okay? So agitation is going to make it go faster, and and then also the temperature, okay? So a few of these factors, okay. Getting back to the curve itself, which salt is least soluble in water at 20 degrees C? Well, as you notice, everything starts at 0 here, and then the temperature goes up. Everything starts at 0 here, and then the amount that is going to dissolve goes up. So we're going to say that anything up higher is going to dissolve more stuff, more in the water. Things down lower are not going to dissolve as well. So the lowest thing you got down here is the potassium chlorate, which is KClO3, looks like. Okay, so let's look at number 2. How many grams of potassium chloride can be dissolved in 200 grams of water at 80 degrees Celsius? Okay, let's first find potassium chloride. Potassium is K and chloride is Cl. So that would be this guy right here. This is the KCl curve, okay? So how many grams can be dissolved in 200 grams of water at 80? Well, we're talking about 100 grams of water here at 80. We come up from 80 degrees C, and we find out where we intersect the curve and read left until we find out how many grams would be dissolved in 100 grams of water. Well, that would be 50. So you say, well, I have 50 grams of KCl are dissolved in 100 grams of H2O. But now we have 200 grams of H2O over 1. So the grams cancel out, the zeros cancel out. It's 2 times 50 is 100 grams of KCl. And that would be our answer. At 40 degrees C, how much potassium nitrate can be dissolved in 300 grams of water? Okay, let's find potassium nitrate. Potassium, K, nitrate, NO3. So here it is, right here. There's the curve. So this is the KNO3 curve, okay? If you don't understand what these are, you just look them up in a table, punch them in your computer, and out comes the name typically. Okay, until you learn them. I still struggle with them personally. Okay, so here we go. We have 40 degrees C. How much can be dissolved in 300 grams of water, not 100 grams of water. Okay, so it's times 3. All right, so let's see. 40 degrees, we write up until we meet the curve, the KNO3, and then we go over. It looks like about 42 for 100. So it's 42 times 3. So that would be 126 grams of KNO3. Which salt shows the least change from 0 to 100? Okay, the whole scale. Which one changes the least? And you can see that NaCl right there. It barely moves, right? It's almost stationary. It's almost a no slope line. Okay, so that would be NaCl, right? All the others show slopes, and whether they be positive to some level or negative. The one that doesn't change hardly at all is NaCl, which means salt is relatively the same solubility across from freezing water all the way to boiling water. Okay, at 30 degrees C, 90 grams of sodium nitrate is dissolved in 100 grams of water. Okay, that's the number we want to know, so that's the solubility level. Is this solution saturated, unsaturated, or supersaturated? Okay, let's see. Let's find sodium nitrate. There it is, NaNO3, right? Sodium nitrate. Okay, 30 degrees. Come on up. All right, we're just below the saturation line. That would be supersaturated up here, and this would be saturated on the line and unsaturated below. So it is unsaturated at the moment. Any second later, it might be a little bit higher, it'd be saturated, and then up there will be supersaturated. Okay, a saturated solution of potassium chlorate. Let's find potassium chlorate. K, chlorate is not chloride, so we're looking for a little more here, and that's KClO3, okay? Potassium chlorate, okay. Is formed from 100 grams of water. Okay, that's what we need to know. So it's the solubility level. If the saturated solution is cooled from 80 to 50, how many grams are going to pop out of being dissolved? So let's take a look. From 80, we have this many grams in there, 40 grams. So you have 40 grams at 80 degrees Celsius. Now, how many do we have at 50 degrees Celsius? We fall back to about, I would say that's close enough, 20. So we're going to lose 20 are going to fall. So now you're going to have 20 grams are held at 50 degrees Celsius. So how many, if you had 40 in the solution, now you have 20. 20 fell out. 20 fell out. So 20 grams fell out. There you go. Which compound shows a decrease in solubility from 0 to 100 degrees C? Well, there's 0, there's 100. The only line that shows a decrease slope is the NH3 line. So NH3, ammonia, right? Ammonia. I can't spell either. Okay, there we go. Which salt is most soluble at 10 degrees C? All right, the most soluble would be the one highest on the chart. At 10 degrees C, you're looking way up here, and that'd be potassium iodine. Looks like that there. So let's see. Which salt is the least soluble at 50? Well, it looks like the potassium chlorate. So that would be KClO3 down here. Right there, 50 degrees, right? The one on the lowest level. Which salt is least soluble at 90 degrees? So at 90 degrees, we have what? The ammonia, NH3. And that concludes a little fun inside the solubility curves, defining as related to the change in temperature, not the agitation and not the change in diameters and all that, and some other factors, but in this case, the change in temperature, solubility curve in water. Thank you.